Bandwidth for changelog is provided by Fastly. Learn more at fastly.com.
I'm Thorsten Ball, and it is go time.
It's Go Time, a weekly podcast where we discuss interesting topics around the Go programming language, the community, and everything in between. If you currently write Go or aspire to, this is the show for you. All right, everybody, we are back for another episode of Go Time. Today is episode number 28. It is our last episode before a 2-week break for the holidays. Our show today is actually sponsored by Backtrace and Stack Impact. Today on the show, we have myself, Eric St. Martin. Brian Kettleson is finally back from traveling, so he's also on the show.
Wait, I'm back? Hello?
You're back.
I'm back?
Well, you can leave again if you want. I mean, we're getting used to this whole Brian being gone thing.
Is this live? Wait a minute.
You forgot everything, Brian.
And we also have Carlicia Pinto on the call as well.
Hi, everybody.
And today's special guest is Thorsten Ball, who many of you may have seen a recent book that came out by him, Writing an Interpreter in Go.
Hello there.
So do you want to give everybody maybe a little bit of a background on who you are and kind of the stuff you work on?
Yeah, of course. So as I said, or you said, my name is Thorsten Ball. I'm a software developer from Germany. And at daytime, I develop with the web stack. I work on web applications in the backend and the front end at a startup. And at nighttime or in the early mornings, because I'm a morning person, I like to deep dive into certain computer programming topics like, I don't know, Unix, operating systems. And since like 1.5 years or 2 years, I've been digging into interpreters, compilers, programming languages, and so on. And I've written a book about it on how to build your own programming language and self-published it 4 weeks ago. Yeah. And I don't know, I'm really excited about all of this. I'm excited about the book. I'm excited about programming languages, and I'm excited about like understanding how they work and how to implement them yourself.
So is this something you do as part of your career? Is this a passion project?
This is no. I wish I could do this as part of my career, but as of today, nobody tapped me on the shoulder and said, like, I want you to invent a programming language. But I'm still hoping, fingers crossed. But yeah, this is purely a passion project. Like, I have this weird thing where I discover like a black box in programming, and I go, how does this work, right? And I start to dig deep into it, and then it all looks like magic in the beginning. Like, I don't even begin to understand how this works, and then I dig deeper, and yeah, down in the rabbit hole. Like, I don't know, you learn a lot of things, and I love coming back up for air and like blogging about it, or yeah, like writing a book about it.
So this is the call out. If anybody needs a programming language written, contact Thorsten.
Yeah.
Shoot me an email, right?
I have to say, I got early access to the book and did some read-throughs on it, and it is an amazing book. If you haven't yet picked up a copy, it's well worth the read. I learned a million things, and I've only made it through maybe 4 chapters. It's really good.
Thank you.
We'll link to it in the show notes.
Yeah, it's as deep of a dive as I could possibly handle, and I loved it.
Thank you very much.
It's a good read.
For anybody listening live, it's at interpreterbook.com.
Right.
So it's actually really interesting. So the language that's in it, is this a language you kind of created on the spot, or is this like a reference language that people use for creating mock interpreters and compilers? Where did the language come from?
So the language is actually made up. It's called Monkey, and I made it up on the spot, basically. The thing is, the idea for the language, if you go to interpreterbook.com, you can see what it looks like. And it looks like a cross between C and JavaScript and Rust, right? So that's the syntax. And it behaves like a Lisp, or let's say JavaScript, because it has first-class functions, it has closures, and so on. The thing is, the idea for this language, why does it look like the way it looks, is twofold. The first reason is building a language like this, like a Lisp, right, with first-class functions and so on, and dynamic and dynamically typed, is really easy to get started. If you want to build like a statically compiled language with static types, that's going to be much more complex. And so that's the first reason, because it's easy to do. And the other reason why it looks the way it looks, with the curly braces and so on, is because I was frustrated before I started thinking about writing the book. I was frustrated by tutorials that only show how to implement a programming language that looks like super easy, or it looks like a Lisp, like parentheses, right? And where like the introductory paragraph in the blog post is, let's skip syntax for now, let's skip parsing for now, just use an array. And that was like, wait a minute, I want to know how parsing works. I want to like implement this. And then you read about how parsing works with a really, really simple syntax. And I thought, no, wait, I want to get to I want my language to look like this, and I want to know how to do this. And so that's the reason why it looks the way it does, like with curly braces and so on, because I wanted it to look like a real programming language. And if you learn how to build a monkey interpreter, you actually learn how to parse JavaScript or C or Rust. And I think that's really valuable.
So actually, you just kind of half answered one of the questions I was going to ask. What's the value of learning about compilers and interpreters? Where does that take you as a programmer, and what do you gain from coming away from this knowing more? Where's the take home benefit?
To be completely honest, like for me, the biggest takeaway would be that it's super fun. And it's, I don't know, I work, as I said, I work with web applications all day. And if you develop locally, you have to spin up your server, your database, you have to make external requests and so on and so forth. And if you develop like a programming language, you don't need anything. You only need the standard library, and that is super enjoyable. So that's the first thing. Like it's a lot of fun. And I think I wrote this on the landing page of the book. I think like this is for people who enjoy programming. It's not, you don't get a certificate, and I don't know if an employer will care if you say like you read this book. It's the focus of the book is fun. Like if you love to dig deep, if you love to understand topics and to better understand them, this book is for you. And the other thing is, if you learn how to implement your own programming language, you learn how other languages work, right? And you start to understand why interpreters are the way they are. And you start to understand how Brent and I could implement JavaScript in 10 days or something like this. And I think that's really, really, really valuable, because at the end of the day, a programming language is just a tool you use to get a job done, ideally, right? So this is a tool you use, and I'm of the opinion, the better you know your tools, the better you can wield them. And I'm kind of like, I'm a big fan of understanding the abstractions you work with. So if I'm building a web page, I think you should know how HTTP works. Maybe not in the beginning, but to get the most out of it, you should know one level of abstraction beneath the one you're working on. That's always the phrase I use. And I don't know who said it. I tried to find out one time, but couldn't find the original author. And I think understanding the level beneath the one you're working on gives you a lot more leverage further up. And it gives you a lot more power further up, because you suddenly understand better how the pieces fit together. So that's why I think if you know how compilers work and interpreters work, you can use them to a greater extent. And maybe not only use them, but to be completely honest, I think a big part of a software developer's job is debugging. as sad as that is, but you have to debug and understand problems. And this helps you a lot. This helps you to understand parser errors. This helps you to understand memory leaks. This helps you understand how an object system is implemented. This helps you understand, I don't know, how Ruby and JavaScript differ in certain things and so on.
It's interesting because many of the things that we use are meant to be abstractions, but
Right.
so many of them actually turn out to be leaky abstractions, where when you get into these cases where something doesn't work the way you expect it to, that's typically when it becomes a leaky abstraction. Now you need to actually understand more what happens that one layer down, which is why there's kind of value in that. And it's interesting because like I learned a lot more about software by learning about hardware too.
Right.
So when you start to understand like, you know, a crystal and the clock ticks and things like that, and that, you know, when you're sleeping for some amount of time, it's actually some subdivision of clock ticks and it's not exactly that amount of time, right? You can only get such a close enough resolution to it based on the clock frequency and things like that. And you start to gain an appreciation for some of these things and why things that you may think are behaving erratically or something is just doing exactly what it's supposed to do, that you just,
Right.
you know, that's kind of where your abstraction layer is drawn.
I totally agree. And I mean, we had, before the show started, we had a little chat in the chat room about IDEs, and I'm hesitant about IDEs. I use Vim, like I'm a big fan of it. And the thing is with IDEs, or my problem with them is you're on such a high level in the like abstraction pyramid, right? You're up there in your IDE and you press a button and something happens further down. And if something further down blows up, then you suddenly don't know what it is and how it works and why it blew up. And I think, I don't know, if you understand the lower levels, you can handle these problems better.
Yeah, that part I didn't really understand because I don't see the difference between pressing a button on an IDE and pressing a key or a combination of keys on a Vim or Emacs. I don't know. I'm not sure what you meant.
Oh, okay, what I meant is, if that probably wasn't clear, it's not Vim or IntelliJ themselves, but if you use Vim, and you're probably going to use Git on the command line, right? And you're going to use a curl on the command line and so on. And if you know those tools and how to use them, the tools themselves, you probably understand them better than Git hidden behind like a graphical UI and hidden behind 3 layers of IDE. Does that make sense?
Yes, it makes sense, but not sure if like it's more like you're memorizing the commands versus not memorizing the commands because you have the visual right there. But I don't know. Maybe you can still understand the concepts without using the commands.
I don't know if it's like, this is like a pet topic of mine. So there's this book or essay by Neil Stephenson, and it's called "In the Beginning Was the Command Line." And he starts, like, he talks about his computing history. Like, he started with then Mac, and then he went to Windows and PC and BIOS, and then, I don't know, like, I think it's 15 years old now, this book. Then he switched to Linux, right? And he talks about the command line, and he said it was in the beginning, and in the end, he ended up there again because he felt it gives him the greatest amount of power, right? So I don't know, maybe my argument is the same one. If you can see what you're working with, if you can see more lower levels, you can use them to better, like, to your advantage. And I have the feeling that some software IDEs and so on, they have to, right? They make things simpler, but they hide complexity. And the question is, if you hide complexity, how much power is lost and how much understanding is lost?
I think I see your points because, for example, with Git, I don't use any visual graphical interface because it slows me down a lot. And the reason is with the command line, I can do things a lot faster. And because I can do things a lot faster, I can do more things more quickly. So I get to actually learn more commands because they are useful and they fast enough that it's a big payoff.
That's true.
So if by learning more, I think I get a greater understanding of what the thing is.
That's right.
So I think there's that aspect of what you're saying, I think.
I think the line comes between like usage and implementation, right? So, if you use something that's, GDB or Git tied into your IDE, you understand the principles from a usage standpoint, but not necessarily the implementation details.
Right.
So when things go wrong, the implementation details are usually what matter in trying to diagnose and troubleshoot the problem. And we could say this about any technology, a database, for example, right?
Yes.
MySQL. Like most of us just use it. But when things go wrong, having an understanding of how databases work is without a doubt going to help you. And I think it's just a trade-off of the time involved in learning the tool at that level versus the productivity that you need. So, things like Git or something like that, there may be a slight learning curve, but it's not the same level as learning how a database is actually implemented, like at the disk layer.
Yes.
Like most of us, there's not a lot of value in that, but there can be a lot of value in understanding the operating system, at least at like a surface level and command line and things like that. And it's just kind of a constant trade, I guess.
So I wanted to bring up almost the same point, but from the opposite direction. I've only ever done Git from the command line, and I was in Windows the other day and needed to do a Git operation, and I had the GitHub client, GitHub Windows application, and I opened it up, and I couldn't understand how to use it.
I've been in that boat too.
All I wanted to do was merge master into my branch so I could make sure that it worked, and I clicked buttons I could not figure out how to just merge the master into my branch. I was getting really frustrated.
Yeah.
So it's almost as if those layers of abstraction take away the power of the tools that you're using. I definitely agree with your point.
And everybody who designs a visual tool has a visual aesthetics, and each visual tool is going to be sort of different, and you have to learn. Whereas with the command line, usually the commands have a certain commonalities, like Unix themed, and you can kind of sort of figure out the commands from one tool to another.
Yeah, I'm not against like graphical interfaces. I'm not saying that because some are vastly superior to their like command line equivalent, right? They give you much better understanding. The best example would be viewing your Git commit history, right? And in a graphical interface, that gives you a much greater understanding and a lot more power and so on. And I think you also have to really draw the line somewhere, because if you keep digging and if you keep breaking open those black boxes, I don't think you're going to come away like super healthy, right? You're never going to get done. And
all I need to do is send an email, but I need to understand how a NAND gate works.
That's right. That's right. So yeah, if 1.5 years ago, 2 years ago, I tried to understand how CPUs work, right? And then you dig into CPUs and you understand kind of what they do, and they fetch instructions and they decode them, and then they execute them, and they talk to memory and I/O devices and so on, right? And then you peak below this level and you realize, no, wait a second, they're actually executing 5 things at the same time, and then they're like caching stuff, and then they're pipelining stuff, and they are programmed too, and they're super complex, and I have no clue what's going on anymore. And you have to draw the line somewhere to like, all right, this is the API, this is the level of abstraction I'm going to work with, because you're going to run out of time, right? It's the saying is it's turtles all the way down. Like if you keep digging, you're going to find another level, and another black box.
There's just not enough time to learn all of it either.
Yeah.
And that brings up a good point too, that I was like this at the like earlier in my programming life, trying to just use one tool for a particular thing, and there's absolutely nothing wrong with using multiple tools. There's nothing wrong with using like a couple IDEs, one to do most of the stuff and one to do some like other things that they do better. So, for example, I use a graphical get to see history like you're talking about, but I cannot figure out. Even if I wanted to use it to merge stuff, I've tried it before. I'm like, I don't know how this works. I don't understand it. But for looking at history, is perfect.
Yeah.
And looking at diffs.
That's certainly true. Yeah. That's exactly what I meant. And I don't know, like as I said, you have to decide what to look into, and you have to decide how much time you're going to spend. And what I'm saying is, if you try to understand those levels below you, and even if they at first might not seem related to what you do in your day job, I think there's going to be a payoff if you understand them better. That's what Brian said at the beginning, that a better understanding of hardware gives you a better understanding how, in the end, software is going to work on it.
Yeah, I think it's important to choose your battles too. We've only got so much time and mental capacity to learn these things. So I think it's okay to, take the easier abstractions on the things that you don't care about so much, but maybe don't on the things that are going to help you succeed directly at your job.
Yeah.
So, or your task at hand.
Yeah.
I think it's about time to take a break. And when we get back, we really want to start talking a little bit more about your book and all that good stuff. So let's take a quick break. Our first sponsor is Backtrace.
Software teams use Backtrace to take the headache and guesswork out of debugging across their environments. Backtrace jumps into action when your Go application fails by capturing detailed application state information, including the complete set of Go routines, channels and their wait durations, and my favorite, scheduler information. Backtrace analyzes this state and archives it in a centralized object store, allowing you to explore interesting patterns across your errors and plug rich error data into your resolution workflows. Backtrace is used by companies like Fastly, which is Changelog's bandwidth partner, Limelight Networks, Message Systems, AppNexus, and more. Head to backtrace.io/GoTime to learn more and start your free trial.
And we are back talking to Thorsten Ball about his interpreter book, writing an interpreter in Go, which has been really interesting.
So, Thorsten, I was looking at the blog post from Steve Iggy's, the Rich Programmer Food blog post that you mentioned.
Yeah.
And it's absolutely fascinating. I mean, I haven't got to the end yet, but he talks in detail in a very funny way about why the need for learning about compilers.
Yeah.
And he also mentions that not everybody, even people who have a CS degree, they haven't taken a compiler class because it's optional in a lot of places. And it was true for me. And I remember debating, I felt like I wanted to take a compiler class because it was I was very focused on design and language, but compiler was totally out of my focus. So that was attractive to me. And I thought, well, every compiler is there. So if you're programming, you're using a compiler, so
Yes.
It has to be useful to learn. But in the end, I didn't take it. I thought it would be too niche. I thought that, well, in practical terms, if I'm not going to be building compilers, so maybe it's not going to be so useful. And I so regret not taking it. I wish I knew more. I wish I knew better. And with that, I wanted to start talking about what exactly is an interpreter and a compiler, how they work, and what are the building blocks, and what makes it such a big deal and useful for us to know about.
Yeah. That's exactly the point you make. So I think it's really funny because a lot of people, what you said is absolutely correct. Like, the market of compiler writers is a small one. So you don't see many advertisements or recruiters sending out emails, do you want to write a compiler, right? But a compiler is hugely complex. It's interesting. It has a lot of parts. And if you understand how they work, you can take those parts and use them in other places. And if you look at those parts, you can recognize patterns and then use those patterns again. And for example, so the basic idea behind a compiler is it takes input, which is programming code or code, and it takes this input, transforms it, and puts out something the computer can understand and execute, right? So you take puts hello world and give it to a compiler, and the compiler outputs machine code. And this machine code is much, much longer than puts hello world. And it contains all the machine code instructions that tell the CPU and the computer how to display hello world on your screen. And it does this by having certain stages. You always talk about stages and passes with compilers. And source code comes in on one end, and on the other hand comes out machine code, right? Or some other form of code. Like I don't want to escalate this conversation, but there are certain compilers that do not translate to machine code, but other programming languages, they're sometimes called transpilers. But in the end, it's the same idea. You take source code and output something that the computer can understand. And it does this by first parsing the input. It maybe most of the time constructs an internal tree, a syntax tree, and it then has several passes or phases where it takes this tree and tries to look at it in detail and find out if there's some parts of the tree it can move, like throw away, or if there are some parts of this tree it can fold together, or if there's duplicates, if there are errors, if there are parsing errors in there. And then it takes this tree and it kind of, like, I'm simplifying, right? So it takes this tree and it walks down the tree and it outputs machine code that lets the computer execute what this tree is supposed to mean. It gives the tree meaning. It gives you source code which you input meaning, right? Does that make sense?
Yeah, it does.
Yeah, it makes sense.
You know, one of the coolest tricks I've ever seen with people understanding how a compiler works is actually from a security perspective.
Right.
Or basically, I forget who this was that posted an article about this, but you could rewrite the source code of the compiler, compile the compiler with it, and then compile the compiler with it again, and then it would be in the compiler, but not in the source code.
Yes.
So now anything that you compiled with this, tainted compiler would have your backdoor in it.
Trusting Trust. I think it's like a paper. Reflections on Trusting Trust is the name of the paper by Ken Thompson, who.
Yes.
Yeah, it's super interesting and mind-blowing, actually, if you read it. It's like a science fiction short story on 4 pages.
So let me ask this: why an interpreter instead of a compiler? And actually, a good question for some of the listeners may actually be, what's the difference between an interpreter and a compiler?
All right. So first of all, the difference is an interpreter takes source code as input and executes it, and it doesn't leave anything behind except what the source code tells the interpreter to do. And a compiler takes source code as input and produces something that can then be executed. For example, Ruby, the programming language, is an interpreted programming language. And if you want to run Ruby source code, you take Ruby source code and pass it to the Ruby interpreter, and it executes the source code. And a compiler, like the Go compiler, it takes Go code and produces and leaves behind an artifact, an executable binary file you can then run on your computer, and your operating system and your CPU can now understand this. So that's the big distinction. But, and like, again, it's turtles all the way down. The lines get fuzzy real fast if you start to dig in, because there's certain interpreters, for example, those highly optimized JavaScript engines that kind of cross the line because they're compiling while they are executing. And this is called just-in-time compilation, or JIT for short. So the question is this a compiler or is this an interpreter? Because it takes source code, it then compiles it to get machine code, and it then executes this machine code directly, just in time, right? And the question is this a compiler or an interpreter? And I don't know what the answer is. They're called JIT interpreters or JIT compilers. And yeah, they're really fascinating. And the reason why I chose to explain how an interpreter works is because I think compilers are much more let's say, I won't say complex, but you have to do a lot more to get it working. And I wanted to keep the scope of the book small. And so I only chose to show how an interpreter works as a starting point. Because if you follow the book and you do everything in the book, you get away and you know how a parser works or how it's built and how you can build your own. And you know how to walk the abstract syntax tree. And those are all parts you can use again in a compiler, right? And the other thing is, I'm not a compiler wizard or anything. I'm not compiler expert, and it's still a topic that's still kind of intimidating to me because I don't know everything about it, and I don't really know how those GCC, those big compilers work. And I'm starting to dig in. I tried to build a compiler for the monkey language, or I'm currently building it and playing around with it. And I think if I chose to do that, to explain how a compiler works, the book would have been 200 pages longer. And it was just a question of scope, and it was a question of how easy is it to get started and how easy is it to finish the book. And I think in the end, it's not one or the other, because if you learn how to write an interpreter, you're perfectly well equipped to write a compiler afterwards. And it's, in my opinion, it's the first stepping stone to understand compilers better.
I guess you would have to introduce some form of assembly language, whether that's your own made up assembly language or an actual assembler. You would have to somewhat understand that in order to implement the compiler.
Yeah, that's the thing. I love to talk about virtual machines, but I try not to get into them. So you could build a compiler that outputs bytecode, right? And bytecode is something like made up machine code. It's machine code for a machine that doesn't exist. And it's not as hairy as assembly language or machine code, and it's easier to understand. But at the end of the day, if I were to explain in a book how to compile to bytecode, I have to explain what a virtual machine is. And if I have to explain what a virtual machine is, I'm also going to have to explain what a machine is. That's what you said. You have to understand assembly language, and you have to understand what an assembler is and what instructions are. And then you have to explain how the machine works. And I don't know, the scope blows up, right?
So I was actually going to recommend a book that I read a few years ago, and I'm probably due to read again, that I highly recommend to people. But it's very short, and I don't know whether you've come across this. It's called The Elements of Computing Systems.
Yes.
Yeah, so they call it Nand to Tetris. So if you're interested in it, it's Nand, as in Nand Gate, Nand, to Tetris.com. And it's only about 300 pages, and this is kind of the shortfall of the book, is because there's so many topics to introduce. It moves very quickly through Boolean logic and arithmetic and gates, and how the arithmetic logic unit is composed of these gates. And then it moves up into an assembly language, and then a compiler, and then I think ultimately a virtual machine and a mini operating system that runs in your fake language on top of all of this. But the shortfall of it is it moves very, very quickly, and I feel like it's enough for you to understand how each of these pieces work from an outside glance perspective, but not enough to implement them from scratch.
Yeah.
But the cool thing about each of these areas for self-exploration is they did a really good job at having tests. So, when you're on the chapter about learning about assembly language, they give you a program, that can analyze the output of your assembler and tell you that it's wrong. They give you some sample inputs that you can run to this program and see. And each stage is like that. So they're kind of self-contained in that sense. But really, when it comes down to okay, I want to sit down and I want to build the virtual machine.
Yeah.
You feel like you could cobble something together, but you don't feel confident enough in what you learned in that quick chapter to just sit down and write one.
Yeah.
So now that kind of your books come along in a language that I'm super interested in, I kind of feel like I want to reapproach that book and now read your book for a better, implementation of that. And it'd be kind of cool to start seeing some of the other areas implemented too. You're talking about virtual machines and things like that, almost like reference implementations.
Yeah. So this book is amazing. It's actually, and I'm not joking, it's actually what holds up the microphone on which I'm recording this. So the microphone is is sitting on top of the book, right? And I read this, I don't know, 2 years ago, and I have the exact same feeling as you just described. It's an amazing book, and they have a really good software suite you can download and execute and example code and so on. But I was still getting frustrated, like you just described, because I don't know, like you said, you walk away from the book and you think, I kind of got this, but not really, right? And you can invest a lot of time in it. And I don't know if then you would get a proper understanding, but then is the question, could there be an easier way? And I think the book is written by two computer science professors, or correct me if I'm wrong, but I think so. And they actually teach the contents of this book, and they have courses on this, and they have lectures on this. And if you have this in combination with the book, like a teacher like that guides you along the way and gives you sort of additional information and hints and tips and tricks and so on, this would be an amazing course to take. And the thing is, there are a few other books like this, and like if you look at compiler books, most of them have at least 600 pages, and everybody always recommends Dragon Book, and I think it has 900 pages. And those are books, their target audience is not like you or me sitting at home on a Saturday evening, like I'm going to program something today. Their target audience is probably students sitting in college or university and trying to really study compilers. And their target audience is also other professors or computer science experts. And that makes it really hard to digest. And that actually kind of kicked off the idea that I should write a book, because to be honest, I love hand holding. I love if someone walks me through, like, go from this to this in these steps. I love this. And there can't be too much hand holding and explanation. And that's what I try to do, like fill the gap between, I don't know, let's say an everyman's interpretive book. I don't know.
Well, I think for most of us, that don't have large academic backgrounds, it's really that source code or it didn't happen type feeling, like
that's right.
If I see a white paper on something, it's like, this is really interesting, but I don't feel like I have the academic background to look at the mathematical proofs and be like, oh yeah, I totally get this, right?
Yeah.
Like, it doesn't matter if it's just cobbled together code, that isn't meant for production use, but just seeing the code itself, the reference implementation can at least trigger your thought process, and you can see how you could do it differently or more efficiently. But learning about these kind of abstract ideas, especially at like a quick glance, like you've got the book in front of you, mine's sitting over on my bookshelf, but I mean, each of these chapters can't be more than 15 pages. Right. How does assembly language work in 15 pages? I think my assembler book is like 900 pages,
Right.
It's just, so you kind of need those, a little bit of hand holding, or at least some reference code that you can break and fix again and get a better understanding for how each of the pieces work.
Exactly. So the point is, in my book, or like I wrote this on the landing page, the center of the book is the code, right? It has 200 pages, and I guess, I don't know, like half of it is probably code snippets. And in other books, I have like a few other compiler books sitting right here on the desk too. And the code is at the end of the book or in the appendix, right? And the code is, let's say, how to say this correctly, it's not the most cleanest code or the most modern code.
Or it'll be pseudo code.
Yeah.
Like you can't even compile it.
Yeah, you can't compile it. You're probably not going to find the compiler that could compile this 15 years ago. And that's kind of, I don't know, that makes it really frustrating, because if you have code on your computer that's like in the book and you can actually copy and paste it or type it, that gives you like, it changes, let's say, the ergonomics of the book, because you can actually play around with it. You can experiment, you can make modifications and so on. And that gives you, I think, a much better understanding how something works, right? And I recommend, in the introduction of the book, I recommend that if you want to get the most out of the book, read it and try to like type off the code or follow along by writing out the code or copy and paste it. But try to follow the steps by actually building the interpreter, because I think that's how I learn the best.
Carlicia, you mentioned, I think, on a prior show that there's a Coursera course for it. Is she still here? Did we lose her?
Uh-oh. Carlicia's down.
I'm sorry, I was muted. I'm sorry. I just found the link for the course and I pasted it on Slack. And the next session is going to start on December 19th. I should do it.
Do it, definitely.
Yeah. I'm definitely doing it. I'm just questioning if I should do this one.
No, it's really good.
It's all about time.
If somebody wants to do it with me, ping me. You'll motivate me.
If I delay our barbecue project any longer, Brian will probably come over here and kill me. So
that's not true.
If you want to wait till I finish that one or get further along on it, I'll do it with you. So I think we're at a good spot here to take a second sponsor break. When we get back, I know that imposter syndrome is another thing that's kind of near and dear to you as well, Thorsten. And especially, talking about compilers, interpreters, and things like that. I know that can kind of make people feel, feel the imposter syndrome even more. So let's take a quick sponsor break. Our second sponsor today is Stack Impact.
When it comes to profiling and monitoring the performance of your Go applications, Stack Impact is a great service to help you and your team laser focus on hotspot profiling, bottleneck tracing, health monitoring, and more. Stack Impact gives you the necessary historical deep dive performance visibility into your Go application's execution so you can discover and resolve performance bottlenecks with line of code precision. Technically, Stack Impact makes Go's built-in profiling capabilities usable in a production environment. Stack Impact does everything automatically. There's no need to run commands or waste time specifying what to monitor. They've even put their Go agent on GitHub under the BSD license. So if you need to focus on the performance of your Go applications, check out Stack Impact. Head over to stackimpact.com/GoTime to learn more and tell them Brian from GoTime sent you.
And we are back talking to Thorsten Ball about his Go interpreter book and all things compilers, interpreters, and learning low-level development. So before the break, we kind of brought up imposter syndrome. So why don't you talk to us a little bit about that? Because the whole idea about learning hardware or compilers and interpreters and garbage collection and all these things, I know, especially for people who don't have academic backgrounds, can kind of make a lot of people, myself included, feel inadequate to do the jobs we're hired for.
Yeah, that's like, okay, so I'm a self-taught developer. I didn't go to college or study computer science, and that's always in the back of my head, like thinking, oh, I'm missing something here, right? And I think imposter syndrome is something that everybody experiences, like developers in general, even if they studied computer science. And I think it's a perfectly natural feeling to have. And in certain areas, I think it's like compilers, for example. This is a hugely intimidating topic because compiler authors, they're like hailed as some kind of wizards or heroes, or they're doing some kind of black magic. You probably wouldn't understand it, right? And the textbooks have all this academic feel to them, and they have mathematical notation in them, and they talk about a lot of formal things and so on. And it's really intimidating. And what I found out, or what I experienced in the last years, is every topic that at first feels super intimidating loses this appeal once you dig into it, and you start to realize, wait a second, it's not really magic, and actually it's pretty easy to understand here, and then you grow up your understanding and you understand more, and in the end you lose all your fear and all this feeling of I'm not worthy enough to understand this, because you suddenly realize, oh well, actually it's just this and this. It's not this huge thing I made it out to be. And the big part of it is like trying to get over yourself and trying to tackle this and trying to get an understanding of it. And the other thing is, one of the big things with like imposter syndrome is that you always assume that, oh, the other people, they know much more than I do, right? So, I don't know how compilers work, but it seems like everybody else does. Or I don't know how interpreted languages work, but everybody else does, and so on. And I think that's a fallacy. It's probably everybody knows that it's a fallacy, and you still get the same feeling anyway. But the thing is, if you get to know these other people that are super experts in these topics, in these super specialized topics, you start to realize that they don't know certain things you know. You can probably find like 20 compiler writers, which you made out to be, or I made out to be, these super mystical computer wizards. And you can find 20 of them that don't know how to use HTML and CSS, right? And if you realize this is a super comforting feeling once you realize that, from the outside, it looks like everybody else has it all figured out. But then you realize, if you peek behind the curtain, no, it's not like that. You know other things they don't know.
I guess it's perception is reality, right?
Yeah.
So there's a couple of things and I posted a kind of famous image for imposter syndrome. It kind of shows a big circle and a small dot, Big circle is what I think other people know, and I'm just a tiny dot in that. And then it shows the reality, which is, you're the circle in the middle, and there's just a bunch of circles around you with some small overlap.
Yeah.
And that's really the reality of it. And kind of, you hit it on the head, right? Like, take somebody who works for NASA and does, computer vision for rovers or whatever, and be like, make me a web page.
Right.
And,
right.
And they're quickly going to stumble too. It's not that they're incapable of learning it, but you're going to be an expert at whatever you spend 8 hours a day doing, right? So you may know nothing about writing video games today, but if somebody hired you in a year from now, 8 hours a day working on video games, you're going to know a lot about writing video games. And it's just
exactly,
it's just that, and Brian and I have talked to people too who work on the Go compiler and things too, and like even they don't give themselves the credit that they should, because we admire their work, but to them they feel like it's micro improvements on things they've been doing their whole lives, right? Like, they're compiler writers. That's just what they do,
Yeah.
Well, I was just going to give an analogy. I sat next to someone I won't name for obvious reasons at one of our speaker dinners at GopherCon, and we were having a discussion, and this is a person I admire greatly from either internal or external part of the Go team. And the conversation we had made it very clear to me that this person didn't understand 2/3 of the things that we do writing APIs for the web at all.
Right.
No clue about how HTTP works or any of that. And I thought,
right.
This is imposter syndrome. This is really it. This is me knowing some things and this other person knowing a whole lot of different things, but in a very specialized way. And that brought the whole thing to light for me.
Yeah, there's no one greater than the other. It's just different.
Yeah, I started approaching this imposter syndrome from the perspective of, well, I started trying to minimize my imposter syndrome by interacting more with people that I think are amazing. And I don't want to minimize the feeling, because it's real. I feel it, and I think everybody feels it to whatever extent. But when you start, it's funny because you have these people you admire. We always have people we admire, right? And sometimes we have a chance to see them face to face. And we might get shy about talking to them because they're so amazing. And you think, oh my gosh, I'm not at that level at all, not even close. And we don't realize that they are amazing in what they do because they've been doing it for a long time. But they're not amazing in everything. And sometimes you are amazing in ways that they don't even know, like you guys, like Brian was saying about the API aspect of development. And you can totally interact with people like that and even collaborate if you open yourself up for them to help you, for example, and with them keeping in mind that maybe you can help them as well. It's brilliant. And then you start saying, I too have things to contribute. And I think it helps a lot.
Yeah.
Brian Lyles was on, I think it was episode 17 or 18 of the show. And one of the things that I love that he said during that episode is like, stop comparing yourself to other people. Compare yourself to yourself, right? Like today I'm, his analogy was today I'm one Brian, like the goal is to improve yourself, not to compare yourself to others. And like, I think that's a good takeaway. I mean, You should be proud of your own growth at the end of the year and not be so concerned about the way you perceive others. And especially, I think like conferences can do that to people too.
Yes.
Because you see people get up on stage and talk about like these wickedly complex things and things that you think are just completely over your head. And this goes back to the kind of perception is reality thing.
Yeah.
We see that and we perceive that they are the foremost expert on that topic.
Yeah.
And what we don't see is they may have spent, 4 to 6 hours a day for 9 months leading up to that, or the year before, just researching that specific topic. And they laid out everything that they know in those slides. And that's really the depth of it. And then there may be people who, just quickly glance on topics to try to simplify them for the audience. And they know far more about the topic than it leads on in their talk. But that's not what we see. That's not how we perceive it. And that's just kind of like the fallacy of it all.
Yeah. So I think like talks at conferences is a really good example, because you watch those talks and you kind of like, you're in awe because you think, oh my God, they know so much, right? And you kind of have the assumption like in your head that, oh, they made this, like they wrote down the slides in a really fast time, and you can probably wake this person up at night and he would tell me the exact things. But the reality is that this person up there on stage, like you said, spent a lot of time putting this together, and here's the point, researching those topics. It's not said that this person knew everything he's saying on stage before he started working on the talk. And I personally, my philosophy, I think Martin Fowler said this, he writes books to better understand what the book would be about. So he starts and doesn't know everything about a certain topic, and he writes the book to better understand it. And then out comes a book, and everybody assumes, oh, this guy, he has it all figured out. Look, he writes a book. And the same thing is kind of happening. Like I get really shy. People like say to me, oh, you wrote a book, that's so impressive. And I know how the sausage is made now, and I'm always like, no, it's not that impressive, right? It took me a year. It took me a year to write it, and it's just markdown files. And oh my gosh, there's so many spelling mistakes and errors. And
ours was written in XML. Picture that, anybody. Write a book in XML. Like, oh.
So yeah, that's the point. Like if like you said, that's the fallacy of it. If you see how the sausage is made, suddenly you realize, yeah, everybody else is doing the same thing I'm doing here, and that helps a lot.
That was actually something I was going to bring up too with your book. Is you start to learn that in actually trying to write it, you learn far more, because you want to make sure that you're not going to say something incorrectly. So even if you think you know, you research and research and research to make sure that you are pretty certain, or at least have enough evidence to back up what you're saying.
Right. Right.
But I think people think that you just sat down and you're like, I think tonight I'll write a book about interpreters.
Yeah. Let me put down really fast how much I know. It's not like that. So like you said, there were points while I was writing, and I was just going to write the abstract syntax tree, right? And then you think, wait, is that correct? Is that an abstract syntax tree, or is that a syntax tree? And then I went on this, like I researched what's the difference between an abstract syntax tree and a syntax tree. And as it turns out, and correct me if I'm wrong, it's largely a matter of naming things, and some people choose the one name and some people choose the other name. And the same thing, like you write, we're going to build a lexer, and then you realize, is it a lexer, or is it a scanner, or is it a tokenizer? And then you research again, and you learn all this stuff just by like trying to understand it. And the end result looks like I actually know what I'm doing, right?
Well, so on all of that, I would have to defer to you, because in this case, I'm fairly certain you know more than I do about this topic.
Definitely more than me.
I've never written one.
I don't know.
So do you guys want to move on to any interesting news and projects going on in the community? I know we've got a few more minutes left of the show.
Sure.
There's some cool stuff happening out there.
As always.
Really cool stuff. Yeah. So I think we have to start with the Gopher Academy Advent Series blog posts. If you haven't been following along with that, blog.gopheracademy.com. We've had some amazing blog posts this year. One new post every day, and I have to give a huge shout out to Damian Grisky for stepping in this year and helping to herd all the cats for all of the different blog posts coming up. With Eric and I both traveling this month, it was almost impossible for us to do it. So great big giant gopher hugs to Damian for helping to get all of that moving. Really good posts this year.
Without him, I don't think there'd be a series this year.
It was not going to happen. No.
Massive shout out. And, also on the news of Damian, I recently saw that he was promoted to moderator of the Go subreddit, which is awesome.
Head moderator.
Head moderator.
Head moderator. I couldn't think of anybody better.
Chief Gopher on campus.
Chief Gopher on campus.
That's Damian. He is the head gopher.
Speaking of people who can make you feel like you have imposter syndrome, not only does he understand white papers, but he's got like all of them memorized.
Yeah.
And he implements them. Have you seen his GitHub repository? He implements them for fun.
He's just an encyclopedia of white papers.
Yeah, that's pretty awesome.
Yeah, it's super interesting, his repository. It's like there's so much work in there, and it's super interesting.
So the other thing too is the Go blog has a survey on there, which is blog.golang.org/survey2016. And they are kind of reaching out to the community to get an idea for use cases, especially it seems like in particular company use cases and the reasons why people are or aren't adopting and whether they're, continuing to grow within the organization and things like that. So if you use Go inside your company, definitely participate in that, because I have the feeling, as with all of their reach outs to the community, that will, highly impact future Go for all of us.
There's a reason behind that. Yes.
It's to capture your email.
Yeah.
It's all a trap.
So there's a couple interesting news bits and some projects we should shout out. The first thing, this morning, I woke up after, first of all, 8 hours of sleep, which is the first time I've had 8 hours of sleep in like 2 weeks. Oh my God, it felt so good. So I woke up and there is a new IDE from JetBrains for Go, and it's called Gogland or Gogland, or I don't know, something that has
Gogland.
Yeah, something that has gland in the name, and it's whatever on that name, kind of weird. But I downloaded it and it's kind of awesome. I ran it on Windows and Linux. The experience was amazing. It detected my Go path. It detected my Go route. When I went out to open a project for the first time, it dropped me right in the source directory of my already configured Go path and asked me which one I wanted to open. It's very nice looking IDE.
I haven't installed it yet, but I saw some cool stuff with like documentation pop-ups, and there was a couple features where it pointed out in the gutter like recursive calls and all the exit points of a function, and there was some kind of interesting things that I haven't seen in any plugins for other editors.
Oh, nice.
So yeah, it looked really cool, and I know it had some refactoring stuff. That's kind of expected from kind of the IntelliJ suite, but yeah, it looks really cool. I'm too much of a Vim guy, so I can't guarantee I will convert to it, but I might at least download it and play with it.
All of my students ask me, what should I use for an IDE? And many of them want a real IDE. So I kind of feel obligated to test them all out and play. And so far, this looks pretty nice.
Lauren just pointed out in the Go Time Slack that they have a Vim mode plugin. So I guess now I really have to install it.
Yeah, you have no excuse now.
And it's actually pretty good. I tried it. It's one of the better Vim mode plugins for other editors. It's really good.
Interesting. I'll try it too.
You just recently converted too, right, Carlicia?
No, I've been, fully, but I've been going back to Atom a few times. I mean, I've been using Vim for a while, but recently with the Go plugin from Fatih, I went full time. But sometimes I go back to Atom if I'm doing a lot of copy and pasting of stuff.
Is that like a comfort food thing? I used to keep Sublime Text around when I first started Vim. And, it was probably a whole year where I had Sublime open just for when I needed to copy and paste things. And then Eric sat me down. Literally, Eric sat me down at lunch and he's like, dude, I'm going to teach you how to cut and paste stuff in Vim, and then we can move on here.
I ended up like pair programming almost with him in his office for a little while, because I think the reason why is because I was there. Like, I tell him, like, just do what you need to do. Let's cover the things that like annoy you the most. And then anytime you think that something is taking too many steps to do, ask me, and then you'll learn a little at a time. And that's kind of the way to do it. You just kind of have to accept that it's a little slow at first, learning, and then you kind of learn. And then once you have like your kind of foundation of commands, there are quicker ways to do stuff, but you're like, who cares?
Yeah.
Do I really care whether it's 4 keystrokes or 2? No, probably not.
So that was me last week teaching a class on Kubernetes. Actually, it wasn't last week. It was this week. Teaching a class on Kubernetes to system administrators. And I'm on the big projector using Vim. Every 2 minutes, it's, why didn't you use this movement? Why didn't you do this? Why didn't you? It's like, all right, you know what? Next time I'm using Atom. At least then I won't get criticized every 5 minutes.
You got to be elite and use Notepad, remember?
Right.
And that was the thing I remember in the web development world, where everybody would argue over IDEs. Like, no, I use Notepad or whatever Windows text editor is. And it's like, that doesn't make you elite.
Nope.
There's not even line numbering there. Like, I'm not sure. Do you code professionally? Couldn't imagine working 8 hours a day with no line numbers, or, like I can do it without syntax highlighting and shortcuts and all that stuff. But there's some basic stuff like, line numbering that just needs to be there.
Can you actually work without syntax highlighting? Like I've probably only seen this in the Go community, that people like willfully turn off syntax highlighting. And for
Brian is doing it.
Yeah, I turned off syntax highlighting maybe 6 or 9 months ago, and I don't miss it at all. It took me 3 or 4 days, and now I agree with the other people. I think Andrew Durand was probably number one, who said it's much easier to read it without all of that colorization in your way. Now you can read the code rather than be distracted by colors.
Really?
Yeah, I'm with you, Thorsten. I can't even try it. I'm so far out. I can't even think of trying.
I still have it on, but I mean, to be honest, I'll SSH into a machine that doesn't have syntax highlighting and stuff, and I'll work just fine for a little while. Like, it won't bother me enough to try to set it up on that machine.
Nah.
So I feel like I could probably do it, but I think I might want somewhere in between, or at least maybe like functions are highlighted so that I could like quickly scan and jump from function to function or something.
See, I'm glad you mentioned that, because I will SSH into a machine. I'll bring up Vim and I want to kill myself because where is my highlights and shortcuts and everything?
But the thing is, like, if you forget to close a string with quotes, like syntax highlighting is going to tell you right immediately, right? Because it highlights the rest of the line like a string. At least Vim does it. I don't know how other inferior editors.
We're gonna start a war now.
No, I'm not gonna go there. No.
So just to play devil's advocate here, though, that stuff does. So one of the beautiful things about like Vim and things like that is the performance of it, right? But when you have like large files, and especially if they have long lines and you have syntax highlighting, like that can cause like painful issues in lag. So it's almost nice the thinking that would never be a problem with no syntax highlighting, right? I don't know whether I could make that jump. I guess if I use different tools like the tag bar or whatever, in Vim, so that I kind of had the layout of the functions to be able to jump, like something like that would probably make it more easily swallowed. But I don't know. Maybe I'll try it one day, like give it a whole day and see how I feel.
The thing is that like the topics of syntax highlighting, long lines in Vim, this is like, I don't know, it's right at the top of my, this needs to get fixed. Like, I can't deal with this any longer, because I have a meltdown every 5 weeks where I realize it's 2016 and my text editor can't colorize a line because it's longer than like 300 characters and it has like a few backslashes in it, right? And I'm losing it.
We can put supercomputers in our pocket, but you cannot figure out what I meant in my string.
Yeah, and like my colleagues in the office are laughing at me, right? They have Sublime Text open and it's super fast, and I can't mention this because they're gonna laugh at me.
You have to just sit quietly in your misery because it'll only get worse if
Yeah.
you share it with others.
Yeah, I was shaking my fist there and biting my lips.
Like, what's wrong? Nothing. All is well. So
all right, we need to move on. We are running long, and Carlesia and I both have school functions we need to leave for in 15 minutes ago.
All right.
So we should move on to Free Software Friday quickly.
Go ahead. You want to go first?
Me?
Yeah.
I love going first.
You brought it up.
You brought it up. It's your world, baby. All right. So I want to shout out to Buffalo Web Framework by Mark Bates. The website is at gobuffalo.io, and it's not even done yet. So he's probably going to kill me for bringing it up live. But it brought love back to web development in Go for me. Now, I know a lot of you are thinking a web framework in Go, that is sacrilegious. You should just use the standard library. And I used to agree with you until I found Buffalo. If you came from Ruby and Rails like I did, you will find Buffalo about the closest experiences you can come to Rails in Go, and it's awesome. We're using it for the next version of GopherCon's website, which is at github.com/gopheracademy/gcon. And I think you should go take a look at it because it's really awesome. Now, just don't get me in trouble for shouting it out before he publicly announced it, because the website isn't done yet. Sorry, Mark.
We'll just claim that we sent everybody there to look at the really awesome logo.
Which is, shout out to Ashley McNamara for making killer Gopher logos.
Oh, yeah. I've been looking at a lot of her work lately. Awesome. And how about you, Carlesia?
I don't have one, but I am laughing at the logo. It's amazingly cute. I don't have a project today.
And I don't know whether we prepped you on this in the email, Thorsten, but typically every show we kind of just do a shout out to a project that's making our lives easier. Yeah. So if you have one, awesome. If you don't,
I have a shout out, and I promise you, I thought of this before this show, right? And my shout out goes to the Vim Go plugin by Fatih Arslan. I hope I pronounced it correctly. And it's an amazing, like it kind of turns Vim into a lightweight IDE because there's so much functionality in it. And I don't know, like 5 versions ago, I thought this is it. It's done, feature complete. And he keeps putting new and super practical and interesting stuff in it. And the development is really amazing to watch. And it's a great piece of software.
Yeah, it's funny. I agree with you. It was a few versions ago where I'm like, sweet, this has like everything I need.
Right.
And then you add that's new stuff and you're like, I didn't even think about that.
Right.
Like, sweet. So I actually have a cool project that I came across that I've only really tinkered with, but it's called GitQL. And we've been talking about Git. It's like a query language to query against your Git history.
Oh, wow.
Which is actually pretty awesome. Yeah, you can do a select author and whatever from commits, and then you can do where date is between wherever, and that's pretty awesome for when you're trying to search around your Git history for stuff. I thought I was pretty decent with doing git grep and things like that on the command line, but this is actually really cool.
And it's written in Go.
Yeah, it is. I just made an alias in Bash, so when I type git blame, it just runs id-u-n. That was a bad Linux joke. Sorry.
We have to explain that returns back.
ID-u, that just gives me my username back.
It's less confusing if you just replace that with "Who am I?"
Yeah.
Just you're the blame for everything, even if it wasn't directly, it's indirectly.
Yep.
But this tool is really cool.
Yeah, GitQL is pretty awesome.
All right. So I think we are, about 10 or 12 minutes over. And I know everybody kind of has some functions to get to. So we are going to go ahead and wrap up the show. Everybody, happy holidays. We won't have, for 2 weeks, we're going to not have episodes just to kind of close down for the holidays while everybody spends some time with their family and travels and all that good stuff. But we will see everybody back after the new year. January 5th, I think, is the next recording date. I want to thank everybody on the show. Definitely thank you, Thorsten, for coming on the show and talking about interpreters and compilers and all that good stuff.
Thank you for inviting me. It was a pleasure. This was really fun.
That's a great show.
Huge shout out to all our listeners, especially the ones that are hanging out with us in the GoTime FM channel on Slack. Huge shout out to our sponsors, Backtrace and Stack Impact. Without them, we would not have a show. So everybody go check out their sites and products. We only work with awesome people, so definitely check out Backtrace and Stack Impact. And did I get everything?
Got it.
Follow us on Twitter at GoTimeFM, github.com/GoTimeFM/ping. If you want to be on the show or have questions for our speakers or for our guests. And with that, goodbye, everybody. Happy holidays.
Happy Go from us.
Happy holidays.
Happy holidays. Bye.
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 Thank you for tuning in to this year's Go Time. We launched this show earlier this year, and we have been blown away by the acceptance and listenership of this awesome show. We've been working hard to produce this, make it the best for the Go community. So if you have feedback, email us, editors@changelog.com, or go to the Ping repo on GitHub, github.com/GoTimeFM/ping. Submit your suggestion, feedback, whatever. We want to hear from you. Keep listening, and if you want more awesome shows just like this one, go to changelog.com or subscribe to our master feed, changelog.com/master. And thanks for listening.